Okay, and then what else?
This Jeep, or no, the Hummer.
Yeah.
So the guy put a multi-function switch. Oh wait, let me grab the key, I'm sorry.
Okay, no, that's fine. So what we were just talking about is Danner's grabbing the keys for this Hummer that we may be looking at as well. This Chevy Express van right here is the one that the right rear turn signal doesn't work, and my brother has it down to the BCM being faulty, but we want to make sure powers and grounds are good. He didn't go quite that far yet, and that may be one of the ones we're going to work on here today. And then the Hummer
H3. So he put a multi-function switch in for the
customer
turn signals.
Customer did.
And then as soon as he was done, the car doesn't run.
Wait, why did he put the multi-function?
For lighting.
So he had lighting.
But wait till you see it. It's part of a clock spring.
Oh,
it's
no.
It's bad.
So he had lighting issues. So someone told him to put Google told him to put a multi-function switch in.
Yeah, and he said now all my lights work, but the car doesn't run. So then he put a throttle body on it.
Why?
Because it has a code for TAC.
Oh no.
But then I also have a code for ignition switch circuit 2, because when you look at that code, it says the ignition switch that feeds something is different than the feed from the computer, and if the two don't match, it'll set a code. Then it starts telling, it kind of leads you towards the throttle actuator, so they put a new one on. But wait till you look at this.
So this never had throttle actuator codes until he put a multi-function switch in it.
And yes, but look at this
Can't change parts on a code. Don't be a parts changer.
Well, this is the multi-function switch.
Oh no.
So you have turn signals and high beams and cruise control and washers, airbag, clock spring, multi-plug that does everything.
Yes.
This one goes to the airbag. This one goes to the pass lock, I think. Something in the
so there is a anti-immobilizer involved here.
In here, but it's not coming through this, but it's part of the harness because it goes through this bulk plug. And I started wondering if something in this bulk plug got switched. Or something, you know what I mean? I don't know. And then you have, I'm sorry, this one.
So what's this one?
This one, that's the ignition switch. I'm sorry, this is the ignition switch.
Okay, yeah.
And this one I think has something to do with...
So it actually comes through this plug and then plugs in somewhere else.
It's not the, yeah, I don't know. I can't remember. I think this goes into the bottom of the ignition switch, and that might be something with the key in detection or something, because these two go back up towards the harness, you know what I mean? And the ignition switch is here, even though the electrical portion of the switch you're not changing, the wiring harness part you are, because it goes into this bulk connector. And before I called you, I was actually just going to see if I could just plug all this stuff back in with no lights and just see if I have the same problem.
Yeah, gotcha.
You know what I mean? But,
so we're setting an ignition to switch.
It's misfiring heavy.
Which might be a strategy which we've learned with the throttle body code, where they do some stupid stuff.
And I didn't
remember our mass airflow issue with was that thing misfiring? Remember the one with the goofy, it was a mass airflow problem, it had throttle body. We just produced this video recently. It had new throttle body on it. I think it was a Kia or a Hyundai. It just had a bad mass airflow. It had that weird description, like that Korean poorly transmit.
Oh yeah, the van.
Yeah, didn't that thing have some weird misfires when it would
last or whatever, whoever AutoZone was?
And when it would go into that mode, it would misfire really bad. So that might be.
I don't know. Like
effect.
That's just for this whenever.
So you start this now, it's bad misfire. And a hard throttle body code.
And the hard code though is the ignition.
So that's the one that we're going to trade.
You know what I mean?
Okay, yeah, we're going to start on this.
It leads you towards the throttle body. It starts talking about that, and then they put one in, and it didn't fix it. And then they, you know what I mean?
Yes.
But I also have, look, he even wrote down the codes. I also have, because I start checking the fuse box, because I also have the O2 heater circuit codes, which are the same power feed, I think, that goes to one of the TAC legs.
Okay.
And I thought
it's missing.
Well, no, I had voltage at both sides of the fuse from the ignition switch, but I don't know why I have
O2 heater codes.
O2 heater codes. It's on the same. It's all on the same kind of circuit.
Okay, cool.
So,
yeah.
But I saved it in my scanner. Hopefully, this isn't dead.
All right, cool. Well, it sounds like this one will be the most help for you.
Yes. Definitely.
Because I mean, the van, you pretty much have that. It's going to need a BCM,
and it's 2 days away, and we got a program.
Okay.
So.
All right. So if we get a chance, we'll look at the BCM one to confirm for you, Danner. But we'll look at this H3.
Yeah. You gotta hit this forward for it to start because the
park neutral switch.
Yeah. But this is the way it runs.
Okay, cool. And change my multi-function switch, and now it runs like this.
How it runs.
That's crazy.
Like you know, so I don't know where the part came from, or.
Okay. All right, we're gonna get started on this Hummer. I'm gonna grab the scan tool. We got to get some service information, make sure we're ready to go, and then we'll pick this back up in a second.
There's a bunch of crap here.
Yep, throttle body. A box with all kind of Danner writing on it. Old part.
The whole car is shaking.
It's in reduced power mode. It even says it right here. Reduced power. Yeah, this is a prime example, ladies and gentlemen, as to why we do not change parts based on trouble codes. This thing never needed a throttle body, I can promise you that. And yet it's still throwing throttle body codes. All right, let's get scanner on this thing. Okay, so first thing is a code scan. I mean, especially because not only was Danner in here playing around, so was the customer. And I want to read faults, clear them, and then start with what comes back. Caleb, does that make sense on how you would attack something like this? Because we're gonna have random codes from different systems, and that's just probably going to be my first approach. Let me ID the vehicle here. I'm going to do a full code scan on this. There's 10 PCM codes. Heater control, throttle position, O2 heater, throttle position. So all throttle actuator. There's that ignition switch fault that Danner was talking about, 1682. Again, transmission system, we have the same codes. PCM traction control not allowed. That's because of our engine codes, that makes sense. Radio code, I don't care about that one right now. All right, peeps, you see our code list, so we're gonna go back and clear these now. Because this is a hard fault, I am not worried about losing any other information, which you would when you clear fault codes. Code scan this again. So what I just said, Caleb, as you walked over there, was I cleared the codes, and because this is a hard fault, I'm not concerned about missing some data. So when you clear codes, we clear things like freeze frame data, things that would help us troubleshoot, say, an intermittent problem. Not worried about that in this case. Now, right now my codes aren't there, so I cleared them, reread them, no faults. I'm gonna start it as soon as this is done. It looks like it's done. And we're in immediate reduced power mode. And for now, I'm just gonna do the engine from this point forward instead of scanning all systems. TAC motor circuit range performance is the only code that came back. Let's let this run a little bit longer. See if we get another fault. I really expected that. There it is. That's the one I wanted to see. Ignition switch circuit fault and O2 heater control circuit. Those are the guys we're going after, son. Okay? And again, history is key, but if you have a car that came in that only got, you know, this assembly, and then all these problems started, you're certainly not gonna attack the, well, that code just, that's weird. This code's like coming and going. This ignition switch circuit fault. How weird is that? I've seen this before with the Snap-on scanner though, in the all powertrain codes mode. Let's just go to history so it stops doing that. It should be there. It's doing it in history too. Weird is that? The codes are like coming and going. So I'm trying to explain the car and direction we're going, and that's kind of messing me up a little bit. I think for the rookie, that would certainly mess you up. The point I was trying to make to our community and to you, Caleb, for those of you that don't know, it's my son Caleb behind the camera who I'm speaking to. I am worried about the ignition switch and O2 heater faults, not the throttle actuator faults that are here. I think they're related. So 1682 is really the one I'm, what's Danner doing?
Ain't nobody tell me nothing.
Why wasn't that on camera? You missed it.
On a tripod.
You missed it. Hey Danner.
Yeah.
This ignition switch circuit fault. You'd mentioned that the one contact, like this was, it was like a key switch, like just to say that the key was in. It's weird how they're bouncing like that. I don't care.
I thought, well, I don't know, man. This was a couple days ago.
Okay, no big deal. I'm gonna look that code up, the 1682.
Because here's your ignition switch one right here. There's your green pin.
Yes.
And then the other one went in, I thought went in over here. Is there like a...
Oh, right here.
Does that look like, is that where that one goes in? Would that be a key in
It looks
thing?
like it, yeah. Okay. And then the heater circuit faults are all there too.
Yeah.
And weird that these codes are disappearing and coming back. It shouldn't be doing that. I've seen this before on GMs though, where they'll do this. There's your bank 1 sensor 2 heater circuit fault. Okay, 1682. I'm gonna look up this ignition switch circuit fault first, given the history and that there's some ignition switch wiring in here. That's what we'll start with. Maybe I should push the fix it button on here, Caleb.
Yeah, it'll just fix it, right?
Yeah, you know. So this is a 2006 Hummer H3, if we didn't say that already.
We did not.
Some of you guys have been asking me about the service information that I'm using. This is not part of the Snap-on scan tool. I am actually using an internet browser to access it, even though the tab says repair information. The reason it's there is because Snap-on owns Shopkey and Mitchell, and so the two are linked together. To get service information that I'm using, you have to pay for a monthly subscription for it, and it's around $160 a month for the professional version of what I'm using. Now for you DIY guys out there, there is a way that you can buy this same information that I'm using for individual cars for a month access for $20. So if you find yourself in a bind and you can't find the service information you need, make sure that you check the description. In the description section of this video, I'll put the link for the DIY version that you can buy access to service information on the car you're working on. So, you know, even for those of you that maybe do 2 or 3 diagnostic jobs a month for friends and family, and you're making some money on the side, it might be worth going that route. So you spend $60 a month on your cars and you pass that off to your customer anyway, rather than spending the $160 a month for the professional version. So there's options out there. Ignition switch circuit 2. This just says ignition switch circuit fault, and the repair info says ignition switch circuit 2, but there is my chart. Throttle actuator control system uses an ignition voltage supply separate from the powertrain control module if the PCM detects a voltage difference between the 2 circuits. This code said. So you follow that? So this is a throttle actuator control fault. It says it uses an ignition supply separate from the powertrain control. So that's telling me that there's 2 supplies. Wait, hold on. If the PCM detects a voltage difference between the 2 circuits, I have to look at a diagram to better explain that. But there's a voltage difference the PCM is seeing. Ignition on, conditions for setting. Actions taken, don't really care about that right now. Did I perform system check, observe freeze frame data? We don't care about those. This is a hard fault. Turn on the ignition, engine off with a test lamp connected to ground. Probe both sides of the throttle actuator fuse. Danner said that he had done that. I believe we're gonna probably redo that step. Does the test lamp illuminate? Turn ignition off. Probe the TAC fuse with a test lamp connected to ground. Yeah, it's definitely leading us toward the TAC system. Replace the PCM. Okay, I want to pull up, because this is having us go to this throttle actuator control circuit right away, or throttle actuator control, the electronic throttle body. I want to look at a diagram for this. I also have O2 heater codes we can look at. Okay, so throttle body is this guy right here, and it has 2 different potentiometers. That'd be TPS 1 and 2. So that'd be the 6 wires to the right. It's E and F that I'm interested in. Where are they going? Right to the engine computer. That doesn't make sense to me. Like there's no external power that's going to this electronic throttle body. Like every single one of these wires are going to the engine computer. The stuff I'm highlighting right now are all the input circuits. Like every single wire, as you can see, goes to the PCM. So how weird is that? Okay, we have O2 heater codes too. Let me look at those while I'm in here. Okay, O2s are here. It did say 1, 2. Did I mention a 1, 2 heater code, Caleb?
I don't know. Did you?
Yeah. Okay, so there's an ETC fuse. There's a powertrain control relay. What does the ETC fuse power? Those are my O2s. I love that. That is awesome.
What's that?
When you highlight a diagram, it keeps it on the page.
Oh yeah.
I mean, that's phenomenal, because now I can clearly see that that's my ignition 1. The code was for ignition 2 though, wasn't it? So that's the separate one it's using. All right, so I think we're gonna start with that, which is, I think, what Danner had already done, is to monitor I think he put a test lamp on the ETC fuse 46 and 47, which is the underhood fuse box. I want to just get that part done first to get a little bit of direction. We'll go from there. Remember that, 46 and 47, okay? How the hell do I open this hood? Being that I don't have my test light with me, and because we have low voltage codes, I'm gonna get you guys a voltage reading. I have the Mission Impossible song stuck in my head right now.
Why?
I don't know. Like maybe I'm thinking of the wrong song, but it's like detective kind of work, like dun 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 dun. Is that the Mission Impossible song?
I don't know.
Do you know what I'm talking about?
I know what you're talking about.
No, this stuff's just fun. I freaking really love detective work. I really do. What I'll do for you guys for this is I'll use the DC volts, and Caleb in his magic editing can put it up on the screen for you all so you can see it. Should be this guy. That should be 46. Let me make sure. So 40, I might be off one. Just want to make sure I'm getting my layout correctly here. I feel like I'm not. It's important. It's super important that I'm on the right fuse.
Reading fuse boxes has always been your downfall.
Well, it's backwards. It's freaking upside down. I am wrong in where I was. Why don't they print it like that? Like I have to literally look at this inverted, and I hate that. Okay, those are our spares, so I was definitely in the wrong spot. Why do they do that to me? I hate that. I gotta read the freaking numbers upside down too. I mean, is it that hard that they couldn't just...
If the numbers are upside down, are you sure you're holding it?
Yes, because I'm looking at I'm looking here. At least get a shot of what I'm looking at. See if you can get that, and then you can maybe use a still frame. So there's your two lugs for the powers coming in. Those two guys. Here's your relays. There's those two fuses. Here's these relays, right? Keep going down. There's fuses that run this way. So you can see it's exactly upside down. Turn them around. Why is that hard to do? Because if I look at it this way, I have to transfer everything in a mirror image, like from that to here.
Okay, but look. You turn this around and stand where I am right now. It is exactly right.
Well, switch me spots then. That would be a lot easier. All right, good point, Caleb. So this is the 50 row. This should be 49. This is 43, 44, 45. This should be 46. That's 10 volts. Let's see what we have coming into this. Oh yeah, our battery's weak. We have 11 coming in. We need to get a charger on this. So 10 volts there, 10 volts there, and then I said I wanted to look at the O2 fuse too, which is 47, which is right next to it. This is my O2 fuse. Yeah, 10 and 10. So that means that relay is energizing. Let me get a charger on this. All right, so back to that. Yeah, we have 12. 13 volts coming in. The fuse itself, I have 12. And the O2 fuse, 12. All right. I need to go back to my service info here. I don't like that we have the O2 heater codes. That should be pretty straightforward. I wonder what else they touched on here. I feel like we're not getting the whole story. So what we just did is we checked the this powertrain control relay, essentially, is what we just checked by looking at the ETC fuse and the O2. Let's go back to that code again. The hard part about filming these, Kayla, was when you're working on an unfamiliar system, I just have to be systematic in what I'm doing, you know? Mm-hmm. Throttle actuator control system uses an ignition voltage supply separate from the powertrain control supply. So it's not a supply then to the motor, it's a separate supply to the engine computer for the TAC system, which is the ETC fuse, I believe, electronic throttle control fuse. Let's see if this mentions that particular fuse, because it's telling me to, with test lamp connected to ground, probe both sides of the throttle actuator fuse, TAC fuse. I don't see a specific fuse listed as TAC. There's one listed as ETC, which those two terms get mixed up in our field. And they're really one and the same. Let me just make sure that I'm not seeing another like TAC specific fuse. I do not see one. I'm confident, fairly confident, that our ETC fuse listed as ETC here and on the wiring diagram is the TAC fuse they're talking about here in the flow chart. Yeah, and checking that at the engine computer, I mean, I would normally go that direction next because we want to make sure that power get from there is good at the engine computer, which is over there, but I don't want to go that direction because of the symptoms and what was done to this car. But you know, at the same time, we don't know what else they did. Why are the wiper blades missing? Like the wiper arms and everything are off. How weird is that? In this same flowchart, Caleb, as we're debating TAC and ETC, step 6, it says test the TAC voltage circuit for open or high resistance. Okay. Step 7,
which circuit?
TAC. Test the TAC voltage circuit for an open or high resistance. That's step 6, right?
Yeah.
In step 7, it says test the ETC voltage circuit for short to ground. So in the same flowchart, they're using 2 different abbreviations.
Yeah.
The ETC, TAC.
That confirms it then. ETC is that electronic
throttle control, and TAC is throttle actuator control. It's the same thing. So talk about confusion for someone, you know, new to this type of stuff. This is what you see, and that fuse, that's the one that we had tested.
Yeah, that's.
And I don't feel like, given the history of this, I don't feel like it's necessary right now to test from here and make sure we have power to the engine computer because of what was done. But I do have questions on whether or not they were there at the engine computer playing around. Some of you may have caught, as I was doing this test, let me show it to you again. Some of you may have caught that our voltage at this location, so I'm doing a measurement right here on the feed in. Now I'm at 1351. And then on the fuse itself, and this is after a relay. Let me get a good connection here.
12.
Yeah, so we have about 0.9 of a volt difference between the feed coming in and then that fuse, and that's not overly concerning to me because we have a relay in the mix here too, and so you're going to have some drops along the way. At least initially, that's not concerning to me because it's the same voltage that I have on my O2s too, and I know for sure the O2 circuits, even at 0.9 of a volt difference, let's say we did have a 1 volt drop on this PCM relay, I don't think that'd be enough to set O2 heater faults. It might be enough to set the throttle actuator one because we learned in the description, the computer's looking at voltage differences to set this fault code. I'm just hesitant to go to the engine computer, but I'm trying to find a tie-in to what was done there. I guess that's what I'm trying to do first. Before I go to the engine computer. And I mean, this flowchart is essentially checking for opens and shorts, and then you're replacing the PCM. I'm certainly not doing that. I'm gonna look up this P030. So 30 is bank 1, 36 is bank 2. Basically the same flowchart for both of these for the heater circuit. Heater supply voltage, open fuses. So we can maybe look at current flow on the scan tool, which is cool. So those codes, the 30 and 36 O2 code says PCM detects that the actual state of the affected O2 heater low control circuit does not equal the expected state. PCM detects the O2 1 heater current parameter is more than 2.7 or less than 0.7. All right, well, we can try that. That might give me a little bit of guidance here. Let me get some data parameters pulled up for our O2 sensors. See if it offers us heater current. Yeah, it does. 13.5 volts, ignition 1. See, we can also, you guys that have been following me long enough know that the O2 signals we're looking at right now is a bias voltage. And then when we start this, that bias line, this should drop off pretty quick. Yeah, I have no amperage at all on my O2s. And this bias voltage is not dropping like it should be. So the only thing that's going to heat these O2s up now is going to be temperature of the exhaust. So you will start to see these dropping. And of course the downstream, the bank 1 sensor 2 is further downstream in the exhaust, and that's why we don't see that one dropping yet. We see the upstream bank 1 sensor 1 dropping because it's heating up by exhaust gas, but we have no O2 heater current at all. And so I'm almost forced to go to my engine computer next. Shoot, I'm having trouble connecting to the dots here. Hey Danner, I feel like we're missing some information here.
Okay.
Because, I mean, I have O2 codes.
Yeah.
They are on the same, so those two fuses,
yeah.
ETC and O2.
Yeah.
And they're good. I have about a 1 volt difference, 0.9 of a volt difference from the post to there, but it does go through a relay, so you're gonna have some drops.
Yeah.
So I'm not overly concerned about that. What I don't like is as I'm looking at the O2s on the scan tool, I have no heater control. Now granted, the computer has shut those off. I should clear the faults and redo this test. I'm gonna do that. I'm just kind of wondering if they were at the engine computer at all. Do we know? Like, why are the wipers missing? Somebody was playing more than they're telling us.
Yeah, but all the trim stuff's back there. I'm not sure. Yeah, I'm not
and
sure.
This was absolutely fine until they freaking changed that.
That's what he said to me.
Until he changed that part.
Yep, and then when they had the battery disconnected, and then I thought, did they, you know, I was going to ask him, is there a chance you jumped it backwards or crossed the wires? You know what I mean? That was my next question to him.
They did have the battery disconnected.
He said he disconnected it to do that job because of the airbag.
Uh-huh.
And then when he put the battery back together, or whenever he put it all back together and hooked the battery up, it never ran right after that. And I don't know if he surged it, you know.
Because I'm not finding, honestly, a tie-in to anything in there for what I'm doing right now. Okay. You know? Like that ignition switch code just talks about the TAC system. So and basically what it is on the diagram, it has the ETC fuse, which they mistakenly call the TAC fuse in the flowchart, but later in the flowchart they call it the ETC fuse, so a little confusion there. But that fuse feeds specifically a leg. So I was thinking offhand, well, maybe it feeds the throttle body. It doesn't. It feeds a leg in the ECM for the throttle body, and that the computer looks at that leg and a separate leg to compare voltages to make sure we're good for the throttle body. That's so it doesn't go exactly to the throttle body. That fuse goes directly to the PCM. Okay. And so my next step, honestly, is to do a voltage measurement from that supply fuse over there at the ECM, and that's why I brought you back over here. But like, wait, nothing's putting me back there.
Okay. I just knew it came off of the ignition switch was like powering this,
yes.
You know, and when that was part of the wiring harness, I was thinking.
No, maybe it could be that
it's not the switch itself. It's just, I mean,
unless I have another power that I'm missing that the computer's using, like the ETC fuse is alive, but maybe I'm missing another power feed that
it compared it to something.
It does compare it.
And I didn't know which. I didn't know that far.
I haven't either, and I don't know if that comes from up there or not on that whole assembly. I want to try something here real quick though. I'm going to clear these faults. Those O2 heater codes come back pretty fast though. I'm going to clear these and see if I can make...
That would pretty much be in the computer's estimation in open circuit. It would want to see the 12 volts sitting there so it can duty cycle the ground.
On the heaters. That is correct. Yep. Yep.
Yeah, and I was going on the power side. I didn't look, you know what I mean? I don't know, you know. I think there's actually an oxygen sensor in there. I don't know how far they went, you know.
Yes. All right, cool.
That's all I know.
Okay. All right, so I cleared the codes. Some of you guys will definitely understand what I'm doing and why. Those of you that don't, you need to understand that outputs on engine management systems, outputs in general on any computer system, when there is a fault present, it is common for the logic to shut down that circuit. And so by me clearing the faults and then showing you this data again, what I'm looking for is, and we don't even need these O2s graphed, I'll keep them ungraphed. Really what I'm interested in is at any point in time, do we get heater current on these O2s? Yes. computer turned them on and then shut them off. Nope, we still got some current here. Brief surges of current, at least on bank 2 we do. Yep. So it wasn't very much current, only jumped up to 0.8. There was some activity there is what I'm saying. I don't know that that gives me any direction, but there was some activity where the computer was trying to work these O2s and then it just decided, no, I'm shutting them off, which is still odd. Weird. O2 heater codes aren't even coming up. I don't have a choice here, Caleb. I think I really need to go and do some checks. I don't know why I'm hesitant to do it. It's basically from symptoms we have, but I need to do some checks at this engine computer. It should be pretty straightforward. So what do we have in here? Freaking turn signals, airbag, clock spring, cruise control, wipers, right, all that. I just having trouble connecting the dots here. Fuse 21, interested in that. 1920 should be this one. Okay, and both sides of the fuse.
13.5.
Okay. Just as I was scrolling through the power distribution diagram, I just noticed the PCM fuse. Just wanted to check it real quick. Yeah, see, that's what I'm looking for, is my ignition switch. It feeds the BCM on this. So the BCM is going to be a smart fuse box in some way, because all of my ignition switch wires feed directly to the BCM. All right, I don't know why I'm screwing around here. I really don't. That's the one I just tested. So I'm just going to my engine computer, Caleb. We're going to do powers and ground checks at the engine computer.
All right.
Those are the two. Those would be the two main ones right there. The ETC fuse is, they call them ignition 1, but they're not. 13 and 19, those would be the two that I'm really interested in first. Let's start there. That's the C1 connector, and it's going to be lower left front of the engine compartment.
Lower left front? Okay.
Well, when we say left side of the car is going to be driver's side when you're sitting behind the wheel, like this is the left side of the car. Yeah. But when they do left side and right side of the engine, sometimes it's not that case.
Yeah. You
put yourself where the transmission is and then look at it from, so if the transmission's over here,
yeah,
the left side of the engine would be on this side.
Okay.
So, but it says left front side of engine compartment should be in here. And that certainly looks like the engine computer over there.
Yeah.
Here, get a shot over here real quick, Caleb. Check out the, you see the dielectric grease like around these two relays. See the white or the clear stuff, right? It's oozing out.
Yeah. Let me zoom in on that.
So definitely someone was playing around in here trying to, you know, bring voltage back up maybe where they thought it should be. Mm-hmm. I want to get a comparison though of the two power feeds on the engine computer. I just don't know that this is it. C3 connectors, 56 pins, and then the C2 connector is 73 pins. So that makes sense. We look at this connector, it's going to be a hard angle for you, but the middle one's a fatter connector. See the two smaller ones?
Yep.
The C2, that makes sense. This is my engine computer. I just got to figure out which one the C1, I think it was the C1 connector we want. Yeah, C1. So pin 1 and 2 are blank, and gray black is the first wire. I'll get out of your way here in a minute, Caleb.
You're fine.
I need to turn my key off. Really not a good thing to unplug computers with the key on. All right, so I said 1 and 2 were blank, and then what did I say? Pin 1 and 2 aren't used, and then we have a gray black on pin 3. See if we see that. Yes, we do.
So that's it?
Yeah, here, come here. It's gonna be hard to see it, but first 2 pins are blank, and that is a gray black right next to it. And then 2 more pins down, it looks like we have a green with a white. Let's go look at the diagram. Dark green and white, that's exactly our connector. All right, so what we're interested in is pin 13 is pink. You stand here, Caleb, and read me these numbers when I ask you, okay?
Yep.
So we want a reading on 13, which is pink, right? The one right,
yeah.
The one right next to that, is it purple? Is pin 12 purple?
Yeah.
And is pin 14 empty?
Yeah.
Okay, good. So that's my first one that I want. And then the other one's 20, which is what color, Caleb?
I thought the other one was 19.
It's highlighted for you there. 19, yes. Pink.
Yeah.
Pink.
Why you doubt me?
Ow! 13, 14, 15, 16, 17, 18, 19. Okay, so I see them both.
Do you want me to switch it to the, I don't know how my kid.
Well, what I need to do is plug this back in, because I want to do loaded circuit voltage measurements. We never want to do unplugged voltage measurements, because it's not an accurate test. We want the circuits to be loaded, and I may need to get a little creative to be able to do this. Now we could, just use a test light in a pinch. We can load the circuits with a test light, but I want to try to grab these. Phil's electric probe it is. Something real quick, side note, last time we used our Phil's electric probes, I misrepresented the tool, mentioning that one, I can put my test leads in and the other one I can't. Not realizing, as someone commented on my video, which I learned a ton from you guys, that is a threaded piece that threads in. So I'm missing it. It fell out. You see how it has a straight screwdriver piece, like a slot? You can unscrew that. So it always had it. This one just fell out. Sorry, Phil. Didn't mean to misrepresent your tool. It's always been good. I can't back probe this because of the latch being in my way, so I have to do this differently. I'm just grabbing these wires away from the connector so I can plug it in and do my measurement. I guess I really didn't need to show these together, but
which is which?
I don't know.
Huh.
Doesn't matter if they're the same when I take my measurement, right?
Yeah, but if they're not, then
if they're not, then it will matter. But let's get this first measurement, and with my digital meter. Oh, we have a problem.
What's that?
No voltage, but I don't have my ground connected. And my leads are too short to go all the way back to the battery. But we're doing comparison circuits here, so having exact battery ground I don't think is super critical at the moment. But I do need at least a trustworthy one. I have to go to the battery, see if I can reach it. This battery it is. All right, that's one. Let's go back. We'll do graphing meter. Oh, we have a problem.
What's that?
I have a pretty substantial voltage difference. I have 13.4 on the one and 11.5 on the other. the code says the computer's looking at 2 different feeds for the same voltage.
Yeah.
If it doesn't see that, it sets a fault. We're seeing 2 different voltages. One of them, of these 2 wires, is my ETC circuit. Okay?
Yeah. The
other is just another feed coming into the computer. And so what I don't know is the other feed coming in, is that the one that's being compared? Let me go to the diagram and make this clear, more clear to you guys. Pin 13 is the one that comes from my ETC fuse. As you can see right there, fuse 46 goes to 13, and which one is that for me? Is my green channel. My green channel is 13. Is the green channel the one that's low? Yes, it is. So we have low voltage coming into the computer on that circuit. So it's 12.2 in that location, and it's actually bouncing around. You can see it's wavy. So we have an issue here for sure. And where I want to start is right where this connector is right here, Caleb, on the fuse box. So as we're watching this voltage that's low, I want to just touch this connector right here as I'm watching my voltage line on my green trace, because I know it comes out of here. Pretty substantial corrosion in this harness too. I mean, on the box, at least it looked that way. And then there was the relays. We did have a little bit lower voltage, so what I want to do too is maybe get a voltage reading. I can pull a 3rd channel in. Not that this is necessary. The only reason I'm doing it this way is just for ease for everyone to see what I'm doing. So a lot of things that I show you guys, of course there are easier, faster ways to do things sometimes. But you have to remember, if you're finding me for the first time and you're watching me, that I'm just trying to make it as clear as possible for you guys. And some of the test methods that I choose are dictated around that. It's not just the car, it's to make this as visually a learning experience, as good of a learning experience as possible. All right, and so this one, I'm just gonna go back to our fuse again, our ETC fuse. I just gotta remember which one it is. So 3rd row.
So the Jeep started up and ran good, man.
Okay.
So I probably should.
Here, stay while you're here. Yeah, and that's right there too. All right, Darren, you want to see what I'm doing here? So I'm measuring the two wires at the engine computer, which are these 2. So one of them coming directly from PCM fuse, which is pin 19. Okay. 13 that's highlighted is my ETC fuse. What we have is the yellow trace is PCM fuse. The green trace is the ETC fuse. So we have a clear difference, which should not be there. And then I'm coming.
How are you getting 13 now?
I have a battery charger on it.
Oh, okay. I'm like,
good question, because somebody else is going to have that same question, and I may not have addressed that. And then my 3rd channel, I just pulled it in just to show I'm back at the fuse, the ETC fuse. So the O2 and the ETC fuse, which come from that relay, it's low all at the fuse box. Okay. And we had mentioned that at first. I was like, well, I even said that to you. It's only a 1 volt drop. Yeah. Like if I measure here, you know, we see right, 13.7.
So do we have a relay?
Yeah, it might just be a bad relay.
That would be awesome.
I mean, that would be stupid, but all of that.
Yeah, but who's gonna? I mean, look what people do.
Yeah,
they, you know what I mean. They start putting throttle bodies in. There is a bag with an oxygen sensor in there. They're looking at codes, probably ordering.
I just think it's crazy that the O2 heater circuits, I watch them. They're like not being turned on. So there's like some logic in the computer involved, because maybe the ETC and the O2s are on the same circuit. I don't understand why this would set oxygen sensor faults.
What if we have like a shorted oxygen sensor pulling something down?
That has a lot of amperage? Oh, it's possible too.
But it's not being grounded there, right?
I don't know. I didn't get that far on the O2 circuit. I'm going to stay here with this low voltage.
Sure.
And yeah, I mean, we're going to start by probably swapping relays here if I can. It's going to be one of the ones with the goop on it, and I'm sure that the guys that were playing around probably did that. And my guess is they swapped them. What was the name of that relay?
Okay. Now the feed on the relay side.
Oh yeah, we got to look at that too.
Is it getting?
It's hot all the time.
But is it? It's not coming from the post though, maybe.
It would be. It's hot all the time. So the load side and control side would be coming from the post inside the box.
Yeah,
I think so.
We'd have to look at a power distribution diagram to see if it goes through another maxi fuse.
Yeah, but at least the powertrain it says powertrain relay. Let's see, where's that at on here? I'm sure it's one of the ones that they were messing with, but I just want to be sure. Powertrain 81. 81 is not even one of the ones they were messing with. Let's see. It should be this one right here. I'm gonna wiggle this and watch my numbers. Green trace in particular. Is it moving? No. Yeah, it's dropping to like 11.7. Oh yeah.
11.4.
And you see when I smacked on that?
Yeah.
This would be stupid if it's
just dropped to like 11.3. 10.
Yeah, our problem's definitely in this box. Or relay. This should be the relay. Why did it just go up? So I'm definitely off on my numbers then. I'm really having a hard time with this power distribution box. It's got to be this guy. So how much that changed. Yeah, it's that guy. Oh, shit. Look at the green cruddies, man.
That's not the one you were messing with though.
It was. Well, think about, I'm moving the whole box though. And it was. Look, I'll put it back in and show you.
Fine, I'll just wait to give a shot of the corrosion.
Look how bad that is.
Yeah. let me get a shot of it.
See the green cruddies on there? There's also dielectric. So someone was in here. Someone was in here and tried and attempted to clean it. And so we're gonna have a drop in this box. I'm gonna take one of these other relays and swap it out. Yeah, it's much better. Look at that voltage. Steady 13.5, only a 0.1 of a volt drop. You know, when I first started looking at this, I think I disregarded, remember me even talking about the 0.9 of a volt difference. I think I disregarded it because of what the customer said, which is what? I didn't have any of these problems until I changed that part. That's not true. You know, I'm not saying the customer lied, but something happened along the way that the customer moved something in the process of changing that part. It might have just been disconnecting the battery, maybe trying to disable the airbag. Clearly this is our problem. Going back to this fuse to give you guys a reading here too. And this will be my blue trace on my lab scope. And you see that they're all good now. And this thing should start and run perfectly as long as I clear the codes. And I don't know what I just swapped that to. Let me make sure that I know the circuit that I just swapped this relay to. What did I swap it with? This guy.
Yeah, you swapped it with that.
I swapped it with this one.
I thought you swapped it with...
No, I swapped it with this one.
Are you sure?
Positive.
Okay.
66. 66 is... Well, that's my fuel pump. So that might not be good. We might have some low voltage going to our fuel pump right now. Yeah, fuel pump control circuit code. It's a bad relay, Danner. It's all corroded. I just swapped it over. And so I was just telling everyone, like, sometimes we can't completely trust what the customer tells us, you know? Like, it had nothing to do with this. They touched something in the process of this. Let me stop talking for a second.
Just shut your mouth.
I did swap it with the fuel pump relay, so the start stall probably
is the fuel pump.
Is the fuel
is the relay for the fuel pump.
It was, yeah. So I probably should.
If I have any of those relays here.
Although I did also wipe computer memory. Yeah.
No, it doesn't even start.
Well,
man.
that's
Come on.
because I
thought you were like the pro with this
swapped
stuff.
it. Give me a.
It ran
here.
when it
Give me.
came in here.
Give me a relay. You got one of these?
No.
I do. I know. I'm pretty sure.
Wow.
Yeah. Look how corroded it is. That means that corrosion's in that box too, Danner.
Well, this one was made in Canada.
Save that. Don't throw that away.
Get it?
Yeah. One that's made in China. But it was sitting in my truck. Oh, it's made in Canada. I just read that wrong.
Nice.
That's what the original one was too, is made in Canada. I just can't see. I had my glasses off when I was reading that. Yeah. I got a fuel pump control circuit problem because I had that relay out running perfectly. Let me clear these faults again.
So you changed how many things for a bad relay?
Well, I mean, in this guy's defense, he needed to change this for what?
I know that.
And so the only other thing he changed was the throttle body.
Okay.
And I think he bought an oxygen sensor, was ready to put O2s in this. So he was about to change more parts, and he decided to be smart and pay for a diagnostic fee. And this is a perfect lesson on why customers need to pay for diagnostic work. Now, here's the key, is the customers need to find a place like my brother's shop to bring it to, because there's a lot of shops out there that are just gonna read a code and change a part too. So there's a battle between two different problems here. One being our industry doesn't have enough guys that do what we do, not parts changers, diagnosticians. Our industry doesn't have enough of those, and customers think that they can read codes and change parts. So those are the two conflicts. And you know, I'm doing the best. Caleb and I, we're doing the best we can to change the face of the industry, right? That's not my main goal, but it is a side product of what we produce. We are showing time and time again that you cannot change parts based off of a trouble code. This was a simple low voltage problem, only by a volt, and we had that circuit loaded. When we were checking the fuse was the same voltage as the low voltage over there, and it was 12.5 volts. I didn't check it with it running, but I felt like, that's fine, no problem. That 1 volt drop, just under 1 volt drop, was causing all of these issues. Let's revisit the O2 and see if we see the heaters working like they should be now. I believe that we will see that. There's my heater current, 1.2, 1.4 amps. The up down in that is just simply the min-max scale thing. And let me do one more thing for you guys. We're gonna let this these O2s cool back off. O2 in the heater circuit. I want to show you this bias voltage drop that you can use in case if you don't have a scan tool that shows you heater circuit current. You can actually look at your oxygen sensor bias when you first start the car, and you want to see those bias lines dropping, indicating proper heater circuit control. I want to show you guys that real quick. So we'll let these cool down as I'm finishing up talking, and then I'll show you that test. As far as a repair goes for this, yeah, it needed a relay, but you saw the corrosion's in that box. And so if this guy has any other issues, that entire box needs to be replaced. You could get creative if this was your own car and pull the box apart, try to clean the pins, tighten them up, spray some stuff in there. There's companies that make some good products for corrosion. I'm not interested in that, not my problem. As far as a garage goes, the time that you would spend in doing a repair like that would outweigh the cost of replacing the box. Okay, so in a garage setting, Danner, agree, in a garage setting, you're not going to take that box apart and clean it. You're going to change it, right? Or you're going to get a used part, right?
Yeah, I've tried to do that with, they usually end up being layers of crap you don't want to
For sure. And the time involved, so I'm just letting our community know, like, how do you proceed?
This isn't like an intelligent one, is it? Like some kind of program?
I don't think there's enough wires in that, but I don't know underneath. It might be. I know this, that when I looked at the ignition switch.
Actually, I have some terminal cleaner if you want to spray it on in there.
I mean, that would probably be a good idea if you want to go that route.
Which one was it? The Chinese one?
No, actually it was a Canadian one. I just can't read. So the one I put in was a Canadian model. Okay. The one that we swapped it with was this. This is our guy.
This is the bad socket.
Correct. That's the one that had
the fuel pump fuse.
But listen, I bet you the rest of these, if you pull them, are green and cruddy too. Yeah. So.
And this thing has sat. I know that's the other thing. It sat for a while, and who knows if they left the hood popped and. You know what I mean? Allowed moisture in there. Yeah. I don't know.
But anyway, what do you do in the field in a case like this? You have options. I'll leave that up to you guys. I'm not saying that, that this needs a box right now. If it's my car, I'm probably not putting a box in it yet.
Just drive it, see what happens.
Drive it, see what happens. Let the customer know about what we did, what we found. You drive it. We'll spray it like Danner said with some contact cleaner or whatever we have, and
I had some, but
we'll go from there. You know what's odd to me, Danner, is why the O2s, because did we check that voltage on those circuits with the car running? We never did we? That was the mistake that I made. When we tested that, we never had the car running. Missed an opportunity. That's why I was just thinking about, why were the O2s being setting those codes on only a 0.9 of a volt drop? Because I didn't have the circuit loaded. I bet you if I would have started that car, if I would have started that car, both those fuses, that 12.5 volts would have dropped down to like nothing. I missed that window. Guys, loaded circuit. Loaded circuit test. We'll have to go back and look at the footage. I made a mistake in checking those fuses with just the key on.
You know what you could do is put the old one back in and he could just edit it, you know.
Well, no, do you still have it? No, do you still have it? I want to see if I can.
I keep saying
hell yeah, I could show that real quick.
I don't know if it might not act up now.
I know, well, that's because we moved it, but I think that corrosion's in that relay, because that relay wouldn't even run the fuel pump, Danner. That was my own dumbass fault. That's why I was sitting there, I was trying to explain how do we justify the O2s and why they weren't working. But, well, because I never had the circuit loaded.
I wasn't grounding it, so you would have seen the 12 volts with the key on, engine off.
Yes, exactly. Exactly. Okay, before I put this in and show you the mistake that I made, let's take a look at the scan tool and the bias voltage. And now that you see, let's ungraph the O2 heater current. I want you guys to only focus on the O2s themselves. So we're reading about 445 millivolts on both. What we should see when I start this, those things should drop, both upstream and downstream should drop immediately. That's what you want to see right there, ladies and gentlemen. Both upstream and downstream O2s. Immediate drop in voltage. You see the upstream is already active. The downstream dropped as well. That's a good indicator for heater circuit function. Remember that. And for those of you following along, this would be Chapter 5 material on ScannerDanner Premium and in my book. Chapter 5 is where I teach this stuff. Okay. Let's cover my mistake. Not cover it like cover it up. We'll show the mistake like we always do. We don't edit that out. What we want to show is why we do loaded circuit tests. I'm hoping that this relay is still faulty. We want to see low voltage. Good. I like it. To revisit our first test, now we'll just keep it the way it is, because if you guys remember the when we first started, well, I can show you that too on my fuse. This is now going to match. That's my O2 and ETC fuse coming from the same relay, reading 12 volts. All right, and then there's the other one. I'm not sure which one's which. That one's going to be 12 as well. And what did we say to ourselves? Well, that's a little bit low. You remember, Caleb? Mm-hmm. We had 12.4 right there, and we have, if you remember, 13.8 coming in, and then this is after the relay, and I'm at 12.2, and right away, I guess I just overlooked it. Why did I overlook this? Because the customer said when they changed this part is when this problem started. That's why I overlooked that. The second problem I made, so that's step number one where I screwed up, is believing that. Two is I never loaded this circuit. Okay, so the green trace is going to be the same as that fuse. Watch what it does. I am confident that we're going to see that voltage drop to near nothing because the O2 heaters are going to come to life and load the circuit and pull that down. And it's going to be, it might actually be momentary. And remember, the computer's going to shut those heaters back off. So initially, we're going to see a drop. And then when the computer shuts the heaters off, voltage is going to come back up. But our fault's still going to be there. That's what I expect to see. Starting it up. Can't believe I didn't check that to begin with. That's all I needed to do. That's all I needed to do, Danner. Loaded circuit, voltage drop, testing. Did I have those fuses loaded with the car off? Answer is no. And then thinking about this further, it's not just the O2. So what I just said about O2s being active and then shutting off and this voltage coming back, the reason we didn't see that is because this circuit's being used by the engine computer to control the throttle body. So if I were to unplug the throttle body right now, I might be able to get that voltage to come up. No. Computer's still trying to do stuff on that circuit, which is why that voltage is remaining low. So that part of it I did not properly explain, but the key with any voltage measurement is a loaded circuit, and I missed it. We could have been, sorry.
That scared me so bad.
We could have been done with this car in 5 minutes. You know, of course, there's going to be GM techs out there that knew right away, and they've seen this problem a million times. You know, oh, it's a bad relay or it's corrosion on the relay. That's fine. For us, not knowing the system, having to do research, it took us a little longer, but you see was able to be done. Danner, I feel a lot better about this box now. One more time, watch it and start it. That's an awful sound.
Yeah, it is.
Oh. Got to clear the faults. Fire in the hole. Loaded circuit, people, loaded circuit. For you guys that want a little bit more info on voltage drop testing, we'll put a couple relevant videos in the description here for you guys. So make sure you guys like and comment, and also hit the bell icon on my channel so you get notifications of when I upload new videos. And if you want more automotive diagnostic training, come visit my website, ScannerDanner.com. I have an online class, you could call it, with over 400 videos, maybe 415 right now. As of October 30th, 2019, we have 415 videos with hundreds and hundreds of classroom setting type stuff where I can explain systems, operations, designs, and then hundreds of exclusive case studies, and it's all for $11 a month. $11 a month is super cheap. You cannot find the education I'm offering anywhere for the money that I'm asking for. And ask around. This is foundational information, giving you a platform to stand on, giving you a platform to build on, that when you go to a garage and you start working in the field, you'll have this foundation and your path will be skyrocketed by that information. I promise you. Ask people all over the world. It's changing their lives. Guys, thank you so much. Yes, we ran in circles a little bit with this one, but a very, very good learning experience. I hope you guys liked it. Caleb, thanks for being here. Danner, thanks for letting us use your shop. See you guys next time. I was just wanting to maybe, if this doesn't prove to show it, maybe we exclude it. But I'm wondering if I would have started with my test light, could I have seen it? Oh, I pulled the relay out, dumbass. All right, so this is the bad relay. If I would have started with my test light, because like, here's what it should look like. That's what it should look like. Yeah. And if I would have started with my test light, the test light is a load. So if I would have started with the test light, I would have known right away we had a voltage drop problem. Instead, do you remember what I said? I was like, oh, I'm just going to use the meter because it's easier for you guys to see, and we wanted an actual voltage measurement. So
that's right, you didn't have your test light.
There's the same, right? That's with the good relay.
Good relay.
Now I'm setting fault codes again. Here's the bad relay.
Dude, I can barely see that.
Yeah, I mean, it's worse now that I played around with it. Oh, but the relay clicked. That means it's good. This relay clicked. Should have started with my light. Should have started with my test light. We would have caught this right away. Would have been done 2 minutes. So what's the lesson there? The lesson is the voltmeter is far more accurate as far as getting measurements, but if you don't use your voltmeter properly, meaning load the circuit, it can be inaccurate, and your better friend is actually the test light. So a little lesson there on loading circuits. The test light provided a load, caused the voltage to drop, made the bulb dim. Dun, 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 dun.